Welcome to our video presentation on data preprocessing and why it is needed, along with a sample example dataset, which was cleaned and analyzed. Data preprocessing is the process of cleaning, transforming, and preparing raw data for further analysis or modeling. It is important because it helps to improve data quality, handle missing values and outliers, and ensure that the data meets the requirements and assumptions of the analytical techniques being used, leading to more accurate and reliable results. The most important thing to keep in mind about data cleaning is that it's an iterative process. We iterate on first detecting and then correcting bad records. Let's look at some examples. We might have text where we expect to find numeric data, so the word 2 instead of the number 2. Some data items might not be designed according to our specification. They might be missing entire fields, they might have extra fields, or for example with JSON documents, fields might not have the structure we expect at all. We might have numbers that are out of range. How many people do you know who are -3 years of age? The mighty outliers compared to a standard distribution. We might have an American expatriate in the London office who did some data entry and coded in a few dates using the US format. The steps for data cleaning are parsing, correcting, standardizing, matching, and consolidating. Parsing, the process of systematically analyzing data to extract structured information from unstructured data. Parsing involves breaking data into smaller elements for easy manipulation or understanding, often converting textual data into a more readable and processable format. Correcting entails identifying errors in data and replacing them with accurate information. Standardizing ensures uniformity across a dataset by converting data into a common format. It addresses variations in units, categories, and naming conventions. Matching involves comparing data elements across or within datasets to identify records that refer to the same entity. Consolidating, combining data from multiple sources into a single dataset. Data transformation involves converting data from its original format into a format better suited for analysis or processing. This can include normalizing data ranges, aggregating information, or converting categorical data into numerical formats to facilitate machine learning models. The goal is to improve data quality and make it more actionable. This can involve operations like scaling, normalization, standardization. First of all, let's see what feature scaling really is. For that, we need a feature. Suppose X is a continuous feature from a raw data set, and we haven't performed any pre-processing on it to visualize the distribution of X. Let's plot its histogram now. I'm going to divide every value of X by 2, and this shrinks the histogram. Well, this was an example of feature scaling where we literally scale the feature by half. We can also subtract a number first and then divide it by another number here. I'm subtracting by 7 and then dividing by 2. This shifts the histogram to the left and shrinks it here. I chose the subtracting and scaling factors randomly, but if we choose some specific values for them, then we achieve normalization. For example, if we subtract by the lowest value of X and divide it by the difference between the max and mean values of X, then we call it min-max normalization. Let's see how it changes the data. Oh, it's too thin. Let's zoom in a bit. You can see that now the data lies between 0 and 1. And this is not a coincidence. Min-max normalization maps the data in the range 0 to 1. Next comes the most popular one, that is standardization. Here we subtract X by its mean and divide by its standard deviation after applying standardization. Our histogram looks like this. Now, there's a huge misconception among the beginners, that is, if, where we apply standardization, then it makes the distribution a normal distribution. This is simply not true. Don't believe me. Let's take a very skew distribution. If we apply standardization on this distribution, you see the shape doesn't look like a normal distribution, does it? Data integration is a key step in the data preprocessing phase, particularly when handling data originating from multiple distinct sources. This process necessitates the integration and amalgamation of these diverse datasets into a singular, coherent format. Dimension reduction. In some cases, the dataset may contain a large number of features or attributes, some of which may be irrelevant or redundant. Data preprocessing techniques, such as feature selection or dimensionality reduction, can be applied to reduce the number of features while retaining the most informative ones. Let's talk about dimensionality reduction. So here I've got a bunch of points, okay? And these points are in 2D, all right? It's called kind of green and red, but that's sort of a joke. We're not going to worry too much about why it was done that. What you should notice is that in the middle here are these orangish, yellowish points. Do you see why it's RNG? Red plus green makes sort of yellowish or so. So along that diagonal, it'll be kind of yellow. I don't know who did this originally, but it's kind of cool. All right, if you think about these orange points, let's think about how they're distributed, okay? So they have a mean sit somewhere, and they've got a set of eigenvectors, right? They've got a covariance matrix that describes them. They have an axis of least inertia, and then the next axis. So here you're seeing the points. The orange points are x. X bar here is supposed to be their mean. And then we've got the big eigenvector v1 and then the smaller one v2. And the idea is we can represent those orange points by only their v1 coordinates plus the mean. And what that would mean is, essentially, that we're going to think of all the orange points as just being on that line, and all I'm going to tell you is where on the line they are. And we're going to essentially ignore the amount that they're off that line. We dived into the world of data science with a project on the uncleaned laptop price dataset, a treasure trove of info from an online store. This dataset had everything: brands, screen sizes, processors, you name it. But it was a bit of a mess with missing data and odd formatting that needed some TLC before we could really use it. In the mix, we had all sorts of data, lots of categories like brand names and operating systems, and some numbers like screen sizes and storage. The price was our main focus, aiming to predict it from all these specs. With over 1,300 listings, we had our work cut out, but saw big potential for machine learning, especially for price predictions. First up, we cleaned house. Tossed out a useless column and any rows that were duplicates or missing info. We even found some places where screen sizes were marked with a question mark, seriously, and fixed those up. Then we got crafty, breaking down screen resolutions and processor details to see how they affect prices, and made some other tweaks to keep our data tidy. After trimming down to the essentials and converting categories into a format that machines like, we were set for some real analysis. We put a linear regression model to the test, comparing the prep data to the original mess. The difference was night and day, showing just how much good data cleaning can do. This deep dive into data cleaning showed us how crucial it is to prep your data right. It's like prepping a canvas before painting. You've got to get it just right for the masterpiece to emerge. So, thanks for coming along on this journey